In previous videos, I've shown evidence of how the world around us was formed, but a fundamental question remains: how did we get here? The void has always been filled by fanciful stories. The Chinese believed a dragon goddess needed someone to talk to, so she formed humans out of clay from a riverbank. According to Jewish mythology, a god made a man out of clay and then fashioned a woman out of one of his ribs. Inuit mythology describes a raven god who filled the earth with pea pods, and one of these burst open to reveal the first man. But 150 years ago, one book shattered these myths and opened the door to a rational and evidence-based understanding of our origins. But while Charles Darwin and Alfred Wallace jointly came up with the idea of natural selection, they parted company on whether this evolutionary mechanism could be applied to humans. Wallace formulated the idea that animals had evolved, but he couldn't compromise his belief that humans were the work of a deity. But Darwin caved to the inevitable conclusion and called it "my little heresy." The little heresy was first expounded not by Darwin, but by naturalist Thomas Huxley in an 1863 book called Evidence as to Man's Place in Nature. Huxley and his supporters had clear evidence of evolution in animals. What they lacked was direct physical evidence to show that evolution also applied to humans. The search was now on for what became known as the missing link, a fossil that was half human, half ape. We are, of course, all apes according to classification, but for the purpose of simplification, in this video I'll refer to human apes as humans and our common ancestor with chimpanzees as apes. It didn't take long for this new branch of science to find its first piece of evidence. Just 3 years before Darwin published The Origin of Species, the bones of what looked like an oddly deformed human were unearthed in the Neander Valley in Germany. Neanderthal man wasn't the missing link, but it did seem to be one of our archaic ancestors. In 1891, fossil bones from the first real archaic hominid, later called Homo erectus, were found on Java Island. And 32 years later, another Homo erectus skull, Peking man, was found in China. Neither of these fossils were the fabled missing link. They were closer to humans than apes. But they did spark the idea that modern humans may have evolved in Asia. Africa was also beginning to yield some valuable finds, including the Taung child, found in South Africa in 1924. The problem was these didn't fit with another discovery made 16 years earlier in southern England, Piltdown man. But as more fossils emerged from South Africa in the 1930s, it became clear that Piltdown man was the anomaly, not the Taung child. Piltdown man just didn't make any sense, either in its physiology or its geographical location. It only made sense in 1953, when the hoax was revealed. By then, the distribution of hominid fossils had given rise to two schools of thought on human origins: an African origin and a multi-regional origin, the idea that humans evolved from archaic hominids in different parts of the world. But over the next 40 years, paleoanthropologists uncovered the motherlode of hominid fossils. The idea of a missing link has long been relegated to the status of a quaint 19th century preoccupation. Finding fossils that link humans to ancestral apes isn't the problem. The problem is that East Africa has produced so many of them that paleoanthropologists are having a hard time sorting out which are our direct ancestors and which are the evolutionary dead ends. We find what we find in most animal species, a wealth of relatives. Some branched off and reached a dead end very quickly. Others evolved for hundreds of thousands of years before becoming extinct. So our family tree turns out to be very rich indeed. It's a bit like trying to find the next of kin of an orphaned baby and coming up not only with direct ancestors, but also their brothers, sisters, uncles and cousins. But together these hominid fossils tell a single story. As we work our way forward in time, just as expected, they become less ape-like and more human-like. Well, no one disputes that. But what species of ape? There's clear evidence that some of these apes could light fires and make tools and hunt with weapons. They walked on two legs. But they weren't human either. They had obvious ape characteristics, like arms longer than legs. And why do we see a clear progression through time of more ape-like creatures disappearing and more intelligent and more human-like species appearing in the sedimentary layers above? We never see a species disappearing to be replaced by something less intelligent and less human-like. That might be true in some cases, but not in all. And skull shape is only one characteristic that separates humans from apes. A more slender body form, larger brain size, walking on two legs, having opposable thumbs, these are all crucial human features that we see evolving gradually through time. Evolution from ape characteristics to human characteristics can also be found in the smallest details, from the shape of the pelvis to the thickness of tooth enamel. When the field of DNA opened up, paleoanthropology got its first big break. This completely new field of science would either confirm one of the mythical accounts of our instant creation, or it would confirm the evidence of slow evolution. And guess which one turned out to be right. Or is it? When geneticists investigated, they discovered that humans have only 46 chromosomes, and all the other great apes have 48. So we couldn't have evolved directly from a common ape ancestor. Unless two pairs of chromosomes had fused. Well, there's only one way to find out. I'll let Dr. Ken Miller pick up the story.
So we can scan our genome, and you know what? If we don't find that chromosome, evolution's in trouble. Well, guess what? It's chromosome number 2.
Mitochondrial DNA tells us even more. It shows that our nearest relative in the animal kingdom is, exactly as the fossil evidence predicted, a great ape, the chimpanzee. And when did we last share a common ancestor? Around 5 million years ago, just before the date of the first ancestral hominid fossils. Mitochondrial DNA from a Neanderthal fossil has also been analyzed. It's completely different to every type of modern human, and it shows that humans and Neanderthals last shared a common ancestor around 500,000 years ago. Mitochondrial DNA can only be passed from mother to child, and it mutates at a fairly regular rate. Let's say this woman's mitochondrial DNA develops a mutation, and let's mark it red. Her kids will share the same mutation, but only the girls will pass it on. Several generations later, another part of the mitochondrial DNA mutates. Let's give this one a blue code. Then another one mutates, a green code. Then more mutations. Thousands of generations later, we can see a clear pattern. Closely related people share a lot of similar mutation markers. The less closely related they are, the fewer common mutations they share. But everyone shares the red mutation, which means they can all be traced back to a common female ancestor. And since geneticists know roughly the rate at which these mutations occur, they can work out roughly when and where she lived. The result coincided perfectly with the fossil evidence, around 150,000 years ago in Africa. I've laid out the twists and turns of the last 150 years because science doesn't move in a straight line. Ideas are constantly being refined, updated and amended as more evidence comes to light. There are no foregone conclusions and no preconceptions. Instead, we feel our way in a darkened room, collecting evidence and getting closer and closer to an understanding of the layout. When DNA analysis came along, it was as if a light had been switched on. Nothing in the DNA evidence contradicts what we find in the fossil evidence. Together they give us the broad picture of our origins. In the next video, The Ancestry of Humans Made Easy, I'll show evidence of who these ancestors were and how they left their homeland to conquer the world.